Hi everyone, I'm back with a new tutorial today and I'm having a time of it this week. My laptop died, my new replacement laptop doesn't want to record at 60 frames a second, which I found out the hard way just before, so I've already recorded this once. I'm going to try and make this quick. Basically, I originally wanted to do a camera alert tutorial and show you how you can give your camera some weight. But because of all the issues I've been having with hardware this week, I'm going to try and do a quick one and show you how you can implement a simple camera shake extension method for your camera and make it do lots of cool things. So again, this is a bit of a build on from last week's, juicing power-ups. This is how we can add a really simple effect again, purely through code, and just make the game feel a bit more, I don't know, nice, a bit more robust. There's just a little bit of feedback to the player here, and it's something we can implement really easily. Apologies if I rush through this. As I said, I have had a lot of issues. I've been playing catch up this week with hardware. We had Father's Day today. I was out all day today. I was out all day yesterday for my partner's birthday, and I'm getting married to her in 3 weeks. So we do have a lot going on. So this is going to be a quick tutorial, but I hope you enjoy it. As you can see, I've just got a sample scene set up here, just so we can see that the camera does shake. We'll be doing a little bit in the game window down the bottom here, and then also having a look at it up in the scene inspector. So the actual scene layout itself doesn't really matter. And I'm just going to get started. So I'm going to create a folder called extensions, and inside that I'm going to create a C# script called camera extensions. So I'm just going to briefly discuss what extension methods are. So let's say I want to work on the camera. I can easily get the main camera in the scene by calling camera.main, and then by using the dot syntax here in Visual Studio, I can see all of the methods or functions, whatever you want to call them, that the camera has available to me. And here's a bunch here. You know, get component in children, get hash code, get instance ID. These are all methods built into Unity that I can use whenever I want. But there's not one here called shake. So RS here, there's nothing here called shake, which that's what I want to do. So I'm going to make an extension method. That's what this class is called, camera extensions, because I can then just call shake on whatever camera I want, whenever I want, and that's really useful and really easy. So to make an extension method, the first thing we have to do is the class can't be a money behavior. In fact, it has to just be a plain public static C# class. So any function or method, I'm calling them functions a lot at the moment. I prefer the name method, so I'm going to call them methods. Any method that we would like to make an extension method, we have to make it public and static. Again, because I'm shaking the camera, I'm going to make it a coroutine. I've heard this is sort of not great practice, but I do need to do this, so I'm going to make it a coroutine, so it's going to return an IEnumerator. I'm going to call it linear shake. Now, the reason I'm calling it linear shake is because you may want to implement different types of rotations, like a rotation type shake later, or something else, maybe one with easing. So I'm just calling this linear shake, just to get rid of that error. New wait for end of frame. Okay, so I've created a public static class, but this is not yet an extension method. So an extension method, the first variable is preceded by the this keyword, and then the type. So in this instance, I'm working with a camera, and I'll give it an arbitrary name. This is now an extension method. So I can call this on a camera object, and it implicitly passes the camera in. So if I was to call camera.main.linearShake, the main camera would implicitly be passed in with the this keyword. So this is now an extension method, and I can start doing things with it. So let's make a float called duration, a float called magnitude. And I'm going to add one more feature. So at the moment we can shake a camera for a specified amount of time at a specified magnitude, which is really nice. But let's give the user a little bit more control. So let's make an enum. So for those who don't know what enums are, I suggest you look them up. They're an enumerated type. So I'm basically assigning, I guess, a string, if you want to call it that, or a character to a number. So you'll see there's a lot used for constants, math.py. or mmath.py if there is one, for example, is a constant, which is an enum. And why is my computer trying to format it like that? So I want to give the user access to every combination of axis. So let's go X, Y, Z. Then we'd have XY, XZ. If I can find the X on my keyboard, how did I just lose that? YZ, or all. So these should be all the possible combinations. So we can either do it in just the X-axis. So let's have a look. If I grab the main camera. So we have just the X-axis, just the Y-axis, just the Z-axis, and then we have X and Y, X and X and Z, Y and Z, or all of them. So that should be all the possible camera axes there. And then I want to add this as a variable on the end, so camera axis called axis. So now I'm allowing the user to specify what axis or which axes they would like to shake the camera in. And you can imagine that would be really useful for a number of reasons depending on what you're doing. So I guess the first thing we can do, which is nice and simple, is we can write a loop. Oh, I always make the ends. Float time equals 0. Time is less than duration. Time plus equals time dot delta time. Now we could make that time variable unscaled if we wanted, or scaled, doesn't really matter. I'm going to make it unscaled. So that loop, by adding that loop, again, we talked about coroutines last tutorial. Basically what this is going to do now is it's actually going to run for a second, because this loop is going to yield at the end of every frame, or wait for the end of every frame, increment the time, count it, and then keep going. But there's no use in the coroutine just running and not doing anything. So let's create a few variables. I'm going to call them X, Y, and Z. And I'm also going to create a vector3 called offset. Now I've decided that I'm going to assign a random float variable to each axis, which is what our magnitude vector variable is for. So I'm going to quickly do this for each axis and then explain. So when we pump in our magnitude, we're talking about how far we want the camera to move in that axis. Now this is the maximum magnitude. I've decided to make the magnitude global for every axis. So if I put in a magnitude of 1, then that's the maximum magnitude in each direction. But I've then decided to random a magnitude, I guess, for each axis to make it feel really random. So you could change this and have it only, you know, maybe have the same magnitude or the same offset for every axis. So instead of doing an X, Y, and Z random, you could just have one that's, for example, I don't know, axis offset, axis magnitude, and just apply that to whichever axis you want. I want this to be completely random or feel as random as I can, so I've decided to do one for each axis. However, we need to specify how we want to set those variables. So we're going to create a switch here, and we're going to be switching off our axis variable. So as you can see here, I created an axis variable, and this axis variable is any one of these enumerated values up here. So these are all our cases. So we have a case of camera axis.x, and we'll break that there. And what I'm now going to do is I'm going to order my switch in the same order of my enums as my enum up the top. I just like to do that because it's neat. So X, Y, Z, X, Y, X, Z, Y, Z, all. And then I'm going to also add a default case. And the reason I'm adding a default case, sorry, I'll change these because errors always look bad on the screen when you're teaching someone something. X, Y, X, Z, Y, Z, and all. So the reason my default case is in here is that I don't initially set this offset vector to anything, and it's uninitialized. So if I don't have a default case later, I could potentially be using an uninitialized variable, and that will break everything. So now what we do is we create an offset vector. So that's going to be a new vector every frame, and in this case it's going to be just our X variable. I think you can see where this is going to be going. For the Y, it's the Y variable, and so on and so forth. Then for Z, it's just the, sorry, this keyboard, this is just going to be the Z variable, and we're just going to keep going. Now this is basically just every iteration or every combination of this one, so it's just XY, so XY0, and then we're going to have, what's this, XZ, YZ, and then, let's actually do something properly here. Offset equals our new vector 3, and then all is X, Y, Z. And for our default case, let's just have it do nothing. Because let's assume if I've put in an incorrect camera axis that it probably shouldn't do anything at all. So now we've created an offset vector, and what we're going to do is basically take the camera's position and apply the offset, which is nice and simple. You can see how that works. Every frame we're going to apply an offset to the camera's position. And I've just realized that's very silly. Let's just quickly do this. This should all be inside the loop, which makes more sense. And then at the end of the frame, we're going to remove the offset. So now I've moved all the code inside the loop, let me show you how this works. So when we first run the coroutine, we create some variables. Every frame that this coroutine runs, we're going to random a new magnitude for each axis. Then, based on the axis that the user has supplied, we will go through and determine how we need to apply those new magnitudes for that frame. So in the first frame, we random all these variables, create an offset vector, and then we add this position to the camera's original position. So, for example, we could shift it up to the right and forward it a little bit. Then we wait for the end of the frame. At the start of the next frame, we're actually going to remove that offset. And the reason for that is if we're constantly randoming a position, you can imagine that the camera's just going to bounce around all over the screen, and it's not going to end up back where we want it when we're finished. So by applying these incremental offsets, we're always going to end up back where we were. The other benefit of this is, let's say the camera's moving, like another script actually moves the camera, like it's following a player, and we do this shake, it will still, because we're only moving in offsets, it should still always move with the camera as opposed to like snapping it back to where it was at the very start of the coroutine. So that's really important in making sure that the camera stays like functional and fluid. It's just adding some extra, zest to it, some extra movement. So that's pretty simple. You can see now I've actually moved everything inside the loop properly. So that's going to do this every frame until the coroutine ends. And now I'm going to write some quick code to show you how to use it. So I'm going to go back into my scene, into my scripts folder. I'm going to create a new C# script, and I'm going to call it shake camera. And I'm going to add that to my main camera. Unity can be a little slow sometimes. Come on, wake up. Did that work? So you can see my shake camera script is now on my main camera. And let's add some functionality. So I'm going to very quickly create a public float which we'll call duration, a public float which we'll call magnitude, a public camera extensions dot camera axis called camera axis, and a private coroutine called coroutine. So this is just some really simple test script that I'm writing. So I wouldn't use this in game, but it's just to prove that it works. I'll quickly write the code and then explain what it does. Get mouse button down. So basically what this if statement is going to do is the first time I press the button, it's going to check if the coroutine is null. Because it will be, it will create a new instance of that coroutine, and then every subsequent frame that I'm clicking or holding the mouse down, it won't try and create a new coroutine. This just makes sure I don't double up and run them twice, so you can tell the duration works and other things like that. So we want to start a new coroutine. What do we want to start it on? We want to start it on the main camera. So camera.main dot linear shake. See how now this shows up as an extension available for this object, and it shows up here as an extension. You can see the brackets. Whoa, I can't highlight that. That's a bad idea. You can see that it shows up as an extension method. So that's fantastic. It's so easy to call now. I can just call linear shake, and I'm going to do that with my duration, my magnitude, and my camera axis, which are the three public variables I've declared above, and I can tweak them in the inspector. So let's go ahead and grab our main camera, and I don't know what values to use. Let's try 1, 1, and all. I'll save that. So now when I run this scene, and I hit play, that's crazy, right? That moves way too much, but that works really well already. So again, if I run this and you look up in the scene view instead up the top, you can see that the camera is just bouncing around like crazy in all directions. Now, let's assume that we're working on a 2D platformer, so this is a weird, okay, it's a 3D scene, but we're only moving in the XY plane. I'm just going to make this magnitude much smaller. I can come down here and say, well, actually, I only want to work in the XY plane. And now when I hit play, and I click, can you see that's probably a bit hard to tell, but can you see if I do this? So I'm looking bang on in the X direction here. I know there's still some perspective going on, but if I play this scene and I run it, that camera does not move forward at all. It only bounces up and down. Conversely, I can change it and say, I just want to move it in Z. Now the camera's bouncing backwards and forwards. So you can get really simple and different effects here now just by changing which axis or which axes you want to do your camera shake in. And I'll just show you here if I change this to 2. Whoa, whoops, I clicked on the wrong thing. That's bad. The duration's much longer. So you can now do a lot of tricky stuff in this camera extension. Because we've got a duration and a magnitude, we can, for example, potentially change the duration and magnitude of the shake based on how far a character's forward, or its current velocity, or if we're dealing with a shooter, maybe the amount of damage that someone's taken in a hit, if they get like a critical strike or a headshot or something like that, make the camera shake more. So again, this is really flexible, it's really simple, it's a really nice way to add feeling to things, add weight to things. You know, when two things collide together, two objects collide together, make them shake. So I know that was really quick, and maybe it needs a little bit more explanation. I hope it doesn't. I really hope you enjoyed it. Next time, I think I'm going to be set up properly now. I'll be using my desktop again. I can record on 60 frames a second on this desktop. If you like what I'm doing, please subscribe. Please give me comments, give me some feedback. If you'd like to see anything in particular that you don't know how to do that you think would help make your game feel really nice, that's simple, let me know. If I know how to do it, I'll throw up a tutorial. If I don't, it's a good opportunity for me to learn and try and teach people as I'm learning as well. So thank you for watching and persevering, and I hope to see you again next week.